Hi guys, so today I'll tell you about uh, today's project is when we run a application on a EC2 server, so how the application can manage the load automatically and can scale up the EC2 instances automatically. So what we are going to do is we are going to create an application or a sample application on an EC2 server. But then if the load on the server gets increased, we don't have to manually go and increase the EC2 servers behind. So it will automatically get increased upon the load. So how we are going to do it is we are going to take a load balancer which is going to distribute the load in the on the application's EC2 instance. Supposedly we have three or two or four EC2 instances as like our desired EC2 instances. Supposedly we have three or two. So what the application will do, it will run on three EC2 servers from the when the application starts. But then as the load gets increased, we can put upon the different types of metrics so that the when the CPU utilization or the load is above 30 or 40%, then we can create two EC2 instances and how it gets automatically scaled, the EC2, how EC2 instances automatically get scaled and how the load is distributed among each EC2 instances equally. So today we are gonna see this. For that, firstly, what we're gonna need is we're gonna need a virtual private cloud. We have to create a VPC. I'll show you what we're gonna create right now. So let's just take this. So this is our virtual private cloud. Now, what we are gonna do is in this uh yeah, okay. So in this virtual private cloud, firstly, we are gonna run our EC2 servers inside that cloud and inside these subnets. So firstly, we're gonna create a VPC. Under those VPC, we can create two public subnets and two private subnets. What subnets are? Subnets are the IP ranges. Supposedly, our virtual private cloud has the CIDR block or the IP ranges. Supposedly anything 34.0.0./24. Now, the public subnets and private subnets are those which they have a IP ranges inside the VPC. Suppose the VPC has a uh, IP range of 10.2.2, 10.0.0./24. Then inside that IP range, there can be different IPs and which are the IPs that are allotted to public subnet. So now we are having here two public subnet and two private subnet in this VPC. And why we are taking two? We are taking two availability zone here. Supposedly, we can take US East 1 and US East 2. And that why that we are taking is because the best practice to perform anything is we can create a disaster management recovery. It is what it is known as. So if anything in our first availability zone, if sorry. Okay, so anything happens to our first availability zone, then automatically everything switches to our second availability zone, such that nothing gets destroyed of the application, and the load can be distributed among the both the zones equally. Supposedly, we have two EC2 from the start. One will be here and one will be in this zone. And now what we want is, uh, first let me explain this diagram what it is. This is our VPC complete, and inside this we have two zones. This will be US East 1, this will be US East 2, or US South 1, South 2, anything you could take it. Then in this we have one subnet, public subnet, one private subnet, and same is in here. Now what is happening is our application is gonna be running inside these VPC, and these public subnets are responsible for the internet gateway. This is the internet gateway. What it is it will earlier we were using default VPC. So right now we are making the VPC on our own. So now this internet gateway will what it will do is it will take the internet from anywhere, and also the all the public subnet in our uh, availability zones will be able to access the internet from internet gateway through these route tables. We are going to create a route table. Now we have two public subnet. Now the internet can be accessible to both of the subnets since though both of the subnets are in the same VPC. Now the internet gateway will now our public subnets will be able to access the internet from our internet gateway, and we are gonna create a route table. Route table is the destination. It could be access, it could access internet from anywhere, and the target is from through which it will be able to access the internet. It will be from internet gateway. Now, what is the role of private subnet? Now, private subnet is where our EC2 servers will be running, or the application will be running, and since the private subnet are not accessible to the internet, so what we're gonna do is we are gonna create a NAT gateway here. Now, what the NAT gateway will do is the NAT gateway is responsible for our EC2 or our application to have the access of internet. Now, the NAT gateway. Now, these are the two subnets where our EC2 will be running. Now, since our application needs internet to run, so what it will take is it will take the help of this NAT gateway, and it will supposedly the IP of private subnet is 1 and 1.1. This IP range is 1.2. Now these two EC2 instance require internet. Now how will they get internet is through NAT gateway. Now these will send signals to NAT gateway, and the NAT gateway through the help of internet gateway will provide them internet. Now, why it is helpful is supposedly your application is running, everything is smooth. Now your application needs some updates to get installed on it. So that is why NAT gateways comes into play. So this is the example of a VPC. Now I'll tell you how the load balancer and everything works. This is just the project overview. Now, um, just a second. Okay, so now we are gonna create our VPC, and then we're gonna attach a application load balancer and a scaling group to our EC2 and run any application on it. So for the VPC, firstly we are gonna create a VPC through Terraform. So let's just first write a create VPC. Now once our VPC is created, I'll show you each and every step. Now in this resource is what you're gonna take is as AWS VPC. VPC, and the name we could give it as, for the name you could write custom VPC. Now after this, now what are the things that are required for a VPC? Cider block. Now for cider block, I'm giving it as 10.0.0.0/24. So this is the cider, or let's go for /16. This is the cider block that gonna give to our VPC. What it means is it is just mean the IP ranges from each uh, subnet. Now I'll tell you how. Now let's just enable DNS hostname equals to true, true, and then enable network address usage or DNS hostname, and also there was one thing, enable DNS support, which is gonna be true. These are the things that is required for a default VPC to run. Now apart from that, let's just name our VPC, and we're gonna name as tags, and inside the tags I'll give it now name. Now name will be let's just give it as YouTube VPC. VPC. Now we have given our name to the, this is the complete thing how we are gonna. Now for the provider I have already given AP South one. This is the provider that we wanna create. Now we are just creating VPC in this. Now second thing that we wanna create is we wanted to create two subnets, which is two public and two private subnets. So now let's create subnet. Now for creating subnet, what do we want is the availability zones. Now what, let's just create availability zones. For that, let's just create variable, and we could write VPC for availability zone. Or we could write, let's just, so now we are creating a VPC availability zone. Now the type will be, uh, okay, so laptop is lagging. Now the type that we want for our availability zone, which you want is, now there will be two availability zones. Now for each availability zones, we want to define the type for it. We could go for a long way, but we'll go for like type is list. Now what is this? I'll just tell you. String. Now this is the type. Now description. Okay, so now we are gonna create a subnet. Now the resources that we're gonna create is AP1 South, AP South 1A and AP South 1B. So now we are gonna create a subnet, which is AWS underscore subnet. Now this is the thing, and also eh, eh, okay, now we're gonna create a public subnet. Now after that, what we want is subnet should in subnet is in VPC, no? So now what we want to do is we want to assign the VPC in which you want to create this subnet. So this is what it is being attached. Now what is this is? It is gonna attach our VPC which we created to this subnet. So now how many how many public subnets we want is two. So we could either write two or we could write length. Now length of what? Now there are two availability zones. So let's just create for the length of this. So now what is the number of availability zones there will be that number of subnet. So now there are two availability zone right now. We are creating two public subnets. After that, the CIDR block. Now here comes the important. Now the CIDR block is like the CIDR subnet. Now what does this mean is I'll just show you. AWS VPC custom VPC and also dot CIDR block. Now, what just now happened is it is taking the uh, now the I told you the IP ranges of our subnet or our subnet is the IP range between our VPC subnets, VPC IP addresses. Now our CIDR block for VPC is 10.0.0./16. So our public subnets VPC lies between those. Now now just let's 8 and count dot index. Now count dot index. Now plus one. Now what it means right now, I'll just tell you. Now let's just write tags, and now the tags that I want to give them to is let's just give them YouTube public subnet. Now there are two subnets, so I want them to name one and two. So for that, I'm just giving a. This is the thing how you can give the name to how you can name the subnet dynamically. Count dot index count dot index plus one. Now what it means is what right now happened is it is gonna create two subnets by the name of YouTube public subnet 1, YouTube public subnet 2. Yeah. Now what this means, it's recording, no? Huh. So now the CIDR block, which means is supposedly our CIDR block for VPC is 10.0.0.0/16. Now the VPC or IP for our public subnet will be, now we have given 8. Now what it means is it will create the subnet 1 IP will be 10.0.1.0/24. Now that this count index plus 1 is that we are adding one the first after the in the range between our VPC, the first IP is being assigned to our first public subnet, and the second subnet will get the ID as 10.0.2.0/24. This will be the ID of our second uh, public subnet. Now this is that we have created our uh, two subnets. Now the same thing is the same how we are going to create our private subnets. You just know and just here I am writing. Here I'll write private private subnet. Everything is gonna be remaining the same. Just that index will be 3. So the first two I have already allotted. Now from the fourth I am allotting the IP to the private subnets. Now I could give the name as YouTube private subnet and the count index will be plus one only. Now once you have given this, now the third thing that you want is, and you could go back to here, go recent. Now what you want is you want an internet gateway, then the route table. Now these two things are remaining that you want to make. Now, now we are going to create our internet gateway. Create internet gateway. Okay. So now for internet gateway, now I am creating a resource AWS underscore internet gateway. Now what will you give the name as? Now I could give the name as uh, uh for the wait. Now this is a resource you are creating. Okay. Now what you want is uh, IP Internet Gateway for the VPC. Now the VPC which we have allotted, uh, this is the VPC. Now we want this Internet Gateway to get attached to this VPC. So VPC ID will be AWS underscore VPC and the custom VPC. Now the Internet Gateway is attached to this VPC and the tags that you want to give it to. Now the tags is name. Now name will be equal to, now what will be the name? You could give YouTube Internet Gateway. Now this is the tag that you have given to our Internet Gateway. Now after you created the Internet Gateway, you want to create two route tables. One is for public subnets, one is for private subnets. Now let's just create a route table for public subnet. Now that we are creating a route table for a public subnet. Okay, so now we are going to create a route table for a public subnet. Now the resource that we are going to need is AWS underscore route table. Now AWS route table that we have created. Now we could name as, and now for the route table we could give the name as route underscore route table public subnet route table public subnet. Now we have created a route table and now we want to attach this route table to our VPC. So that route table is in VPC. Now the VPC that we have created, AWS VPC, custom VPC is the name which we have given it. Now route. Now route table routes the traffic. Now what it is gonna public the route table for public, what it was doing is it was distributing the internet or helping the public subnet to get internet through the internet gateway. So the route it or I could say the cider block. The cider block that it is gonna be using is 0.0.0 slash 0. It is what it means is now it is okay. So you have to okay. So its cider block, what it is doing is it is just letting you know that you could access it from anywhere through gateway ID. In the gateway ID, you need to take the help of the internet gateway. Now, by the internet gateway, what we have given the name as AWS underscore internet gateway dot the internet gateway which we have given, which is IGV internet gateway VPC. You could see here. Now, this will this will be sufficient, and now we could give it name or tags for our route table. Now now tags name will be public subnet route table. Public subnet route table. This will be the name for our route table for our public subnets. Now this is completed. Now we want one thing, that is route table association. Now so that now we want this route table to get attached to our public subnets. Now for that, route table association with public subnet. Now the resource will be AWS route table association. AWS route table association. Now we have given this. Now the name we could give public subnet association. Association. Now we have given us the name. Now the route table ID. Now because which route table you want to assign is route underscore table. Uh, just a second. There is a bit. Okay, this is the thing. Now, resource is a root table ID. Now, root table ID is this, the root table which we just now created. So, AWS underscore root table ID and the table ID which is we have created. YouTube root table public subnet. This is what we have created right now. So, we have assigned the root table ID. Now, count. Count is what? Uh, how many subnets you want it to be. So count is again we could go for length and for the length after that number of availability zone. So VPC now we have assigned it to availability zone var dot VPC underscore availability zone. Whichever availability zone will be there, he'll attach it to there to all those. Now subnet ID. Now subnet ID is now you have to enter the ID of each subnet individually, or you could do if you want to attach it to every subnet, you could write this AWS underscore subnet. Now AWS subnet and then the public subnet. Now in the bracket you could write star. Now what it will do is it will attach it to every subnet and then it is the count dot index. Okay, so it will attach it to every subnet that are present in our availability zone. Now we are creating a elastic IP. Why we are creating a elastic IPs, I'll tell you. Now resource elastic AWS EIP, I guess. Okay, elastic IP, and the name we could give as. Now we are gonna attach this to our NAT gateway. NAT gateway. We're gonna attach our elastic IP. Now allocation for ID for our, this will be the location ID. Now AWS underscore elastic IP. Now dot. Okay, wait. Now we are creating a elastic IP. So for that, firstly, what we want is domain. Domain. Now for the domain, we are gonna create as VPC. For what thing we are creating the elastic IP is VPC. Now it depends on. Now we are gonna create it on for the this NAT gateway. So depends on me. It depends on AWS. Now AWS internet gateway is what it depends on. Now this is how we are gonna create our elastic IP. Now once we have created our elastic IP, now we are gonna create a NAT gateway. Now NAT gateway is used to give the private subnet internet access. It is just the gateway in between of private subnets and the internet. Now NAT gateway. So resource, then AWS underscore NAT underscore gateway. Now we could write it any game. Now NAT gateway. Now we have given it as now name. Now allocation ID. Here is what we're gonna allocate this NAT gateway as AWS underscore EIP dot EIP ID. Why is it not coming? AWS underscore EIP dot EIP ID. Now ID ID. Now there is some error. Hmm. Okay, so We have given it as this name. Let's just give it the name EIP. So now this will be fine. Allocation ID AWS underscore EIP dot EIP dot ID. Now this is created. Now Elastic IP and everything is created. Okay, so now you could see that what all we have created. We have created a VPC and we have created subnets, and for subnets we need availability zone. There are two zones that we need. Now two public subnets is what it is creating. Count will be the length of availability zone. Then for the two subnets, now we are creating two private subnets, and then there's an internet gateway. Now the route table. Now the route table has to be attached to two public subnets. Now what that route table is, it is taking it from the internet gateway and delivering it to the public subnets. Then the elastic IP, then a NAT gateway which is gonna attach to one of the public subnet, and after that we are gonna create a route table for the private subnet and the route table association. Two route table for the private subnet is, now it can get from anywhere, but if it wants internet get access, it could, the destination will be AWS NAT gateway. Now after this, what it is doing is it is associating the route table to this private subnet. Now these all things that we have, okay, close. Now till now we have created this. Now these are the all the things that we have created till now. Two availability zone, two public subnet, two private subnet, two route table, one for public, one for private, and their assigned roles. Now these are the things that we have given till now. Now what we want is, we want to, these are the things on which our EC2 server will be running. Now this is how we are gonna do our or make our project. Now what it is happening is, we have creating a load balancer, and we have created our EC2 which is gonna run on our private subnet. Now it could be any number of EC2. Right now you could see four, but we are gonna create two, and once the load gets increased, it goes to four. So what this is doing is, now our public subnet is taking the internet from internet gateway. We have provided it the route table. Now the application load balancer is distributing the load to of the EC2 through uh, now the application is distributing equal load to all the EC2 that are present in our uh, this subnets. Now you could see a scaling group. Now what this is the scaling group. Now what this scaling group is doing is, what it is doing, it is scaling as it is attached after the ALB. Now once the ALB is passed, it goes to inside the subnet and it distributes the load. Once the load increases, it increases the number of, the auto scaling group increases the number of instances. Okay. So now what we are gonna do is, I'll show you first. This is the program, how it looks like. We are the user. We're gonna send a create an application. What, or we're gonna sign into our application or enter the web server. Now, once we enter, there's some HTTP request that we, or there is some load that we give to the server. That load is being, firstly it is being addressed by the application load balancer. Then there is a auto scaling group. Now what is that application load balancer? It has a listener attached to it. What it listener do is, it sends the traffic received by the application load balancer and sends the traffic to the security group of auto scaling group. Now this is the security group. Now what it is doing is, it is now our now the what the thing is, we the security, the application load the security group which is attached to ALB, it should only listen to the user's request, not anyone else's request, and it should send to the request to the security group of auto scaling group. Now our auto scaling group, the security group or auto scaling group should only listen to the application load balancer request. Now we'll create the security group. Now what is this? This listener sends the request to security group. Now, what this is, this supposedly there are two, three instances already there. It is gonna distribute the request equally, and if there is a heavy load, then auto scaling group all will scale automatically. Now we are gonna create our auto scaling group using a launch template. What that is, launch template is uh, AWS provided template. What it does is it provides us a template, a pre-made template in which we have to enter the specifications of our application and how many desired servers we need, minimum servers, and everything is being attached to the template. We have to attach everything to it. We have to configure it, and then we could just launch that template and everything runs automatically. So I'll just show you. Firstly, we're gonna create now. First thing that we're gonna create is a security group for our ALB. ALB is our automatic application load balancer. Now it is gonna take the request from internet and send it, take the request from the internet. Now, now what, how we are gonna make is simply we are gonna go resource, uh, in that resource, gonna go AWS underscore security group. We're gonna name the security group as ALB underscore security group, application load balancer security group. Name we are gonna create is YouTube. By what name you wanna see your see it in AWS is YouTube ALB security group. Now after that, the description, if you want something to write in the description, you could write security group for our application load balancer. Now you have created this. Now you want your VPC. Now, firstly, we created a VPC as well. So you want your VPC to, you want everything to work in your VPC. So you have to attach your VPC because you don't want to go for the default VPC. So AWS VPC, which we have created, is the custom VPC. Now, inbound and outbound route for application load balancer. The inbound rules will be, hmm, wait, huh. So ingress is what is our inbound rules. Now, what are the inbound rules? From port is 80 to port is 80. Now, protocol which we want is TCP. Now, TCP. Now, cider block. Cider block. It is 0.0.0.0/0. Now, inbound rule is our security group can take the request from anywhere over the internet. Now, these were the inbound rules. Now, egress. Egress. Egress is our outbound rules. Now, what are outbound rules? From port 0 to port 0. Now, protocol is -1. I'll tell you what it means is. Now, protocol is -1, and the cider block that we want is uh, 0.0.0, 0.0.0.0. Now, these were the inbound rules. Now, tags. You want to give a tag to this. Now we're gonna give the tag as name. Now we could give the tag YouTube application load balancer security group. Now this is what we've given the tag as. Done. This is the security group for your application load balancer. Now we are gonna create a security group for our this EC2 instance. Second security group for our EC2 instance. Now ALB is gonna send the traffic to EC2 instance. So ALB is gonna send the traffic to EC2 instance. Now resource AWS underscore security group. Now the name of the security group you could give it as EC2 dash security group. Now you're given the name that is in a local. In AWS we want it to be, let's go YouTube EC2 security group. We're given the name. Now description security. Now for the description you could write anything. So now I'm writing a security group for our web for web server that we're gonna run our EC2 web server instances. Now the web server which we have is gonna have this. Now we're gonna attach the VPC ID. VPC ID is AWS underscore VPC and the VPC which we created. Everything has to be in the same VPC. Now inbound rules. Ingress. Ingress is inbound rules. From port, this from port is 0 to port 0. Now protocol TCP protocol. Now let's go. Protocol is -1 and security group. Now security group is from inbound rule is it can take the request only from the security group from the ALB. So we're gonna attach the security group of our ALB. So AWS underscore security group and ALB security group. Now we have attached the security group of our ALB. Now egress. Uh, EGRESS. Egress. Now outbound rules. Now from port 0 to port is 0. Now after that to call -1 and anywhere. Cider block will be anywhere. 0.0.0.0 dash 0. This will be our outbound rules. Now done. Now outbound rule is done. Now tags you want to give it as name will be name you want to give it as YouTube EC2 security group. You've given the name as YouTube security group. Now, okay. So now we are gonna create our application load balancer and target group and listener. Now I'll show you here. Recent. These are the things. Now you have created security group, VPC, and the complete thing which it is working on. Now you want to create application load balancer, listener, and auto scaling group. Now let's just create a application load balancer. Now we are gonna create a application load balancer. Now RC URC resource. Okay, now it's came. Now the resource is AWS underscore ALB. Now, sorry, load balancer. Now the name which you want to give it to as application load balancer. Now you're given the name. Now name. I think yeah. Now the name which you want to give it as YouTube YouTube application load balancer. Now you have given the name. Now you have given load balancer type. Load balancer code type. Okay, so now we're gonna create our we were creating our load balancer. Now there are two types of load balancer: internet facing and internal. So we want our load balancer to be internet facing. We want our load balancer to be like everything it is gonna take is from internet. So it is an internet facing load balancer. So internal is equals to false. Now we have done this. Now the security group. We are gonna attach our security group, which is AWS underscore security group dot application load balancer. This, or what was the name that we have given it as? ALB underscore ALB underscore security group. So we have attached a security group to our load balancer, and oh, okay, we have to attach ID. So we have attached the security group ID to our load balancer. Now, what we want to create is we're going to attach it to our subnets. Now, subnets because our load balancer should be accessible to our public subnets. So, AWS underscore subnet and dot public subnet. Now, this is what we're going to create. Now, we are going to do a bracket and star dot id. Now it is gonna attach our load balancer to all the public subnets that are there. Now what does it depends on? It depends on internet gateway. Now internet gateway IP. Now it depends on internet gateway. This is our load balancer is gonna be made by this. Now which what we want is target group for our load balancer. Application load balancer. Now we are gonna create two target group means where it is gonna be diverting its request. So AWS underscore load balancer underscore target group. Now it is gonna create a target group. Now we could name it as LB underscore EC2 target group. Now we have done this. Now it has created this. Now name. We could go for web server internet web server target group. Now after name we could write port 80. It is gonna protocol is http and the VPC it is gonna attach is AWS underscore VPC and the custom VPC dot ID. Then after that tags is name. In tags you just write the name which is YouTube or YT application load balancer EC2 target group. Now we have created a target group for a load balancer, and then we want to create a listener that it will uh, l- it will like take the request and send it to the security group of uh, auto scaling group. Now we're gonna create a resource AWS underscore LB underscore listener. Now the name of the listener that you want is you could give them any name. I am giving it as AWS underscore listener. TENER. Now, or let's give it the name of ALB listener. Now, now we are gonna attach the load balancer ARN. Oh, there is. Now, LOD. This is how we attach load balancer underscore ARN is equals to AWS dot load balancer. Now Wait. I think it is lagging. Yeah, it is lagging. Oh, okay. So now that we have created the NAT gateway, sorry, hmm, in this. Now the two things that were left are launch template for the web server and the auto scaling group. Now, yeah. Now we have created a launch template. How we are creating a resource is AWS launch template, and we have named it as EC2 launch template. You could name it anything. I've given the name as YT web server. Now the image ID which I have given it as is AMI this. Now where did you get this image ID? Now you go to your EC2 instance. Now you go to your EC2 launch template and you could see you want to create the web server as the EC2 instance as Linux. So you go to Linux and copy this AMI ID. Then you come back to and you paste it here. Then the instance type is T2 micro because it's free tier. Now network interface. Now we want a security group to attach to this. So we have attached a security group here and the user data. Now we have created another file for our user data in which we are launching a Apache web server in which we have written this message is from Pratyaksh web server and then the name EC2 instance IP. Now, what it is doing is it is installing all the updates in it and displaying us a message that this is from Pratyak's web server. Now, here we have attached it in the way. Now, you could even write it here, or you could do it in a simpler way, which is you could just where was it? Uh, Hmm. So yeah, in user data you could write as file base 64. This is a type that we are taking the user data from a file, and now the file is on the same directory. You could see here that the user data is here only. So we have entered the file name, and then it is gonna fetch the code from the file. Now, what other things that we want to do is tags. You could write instance, then the name of the instance. Now comes the main thing, how we are gonna scale it. Now we have to uh, what is auto scaling group? We have to in auto scaling group we have given the name YT web server auto scaling group. Now desired capacity. What is the desired capacity means that what on how many minimum servers that you want your EC2 to run. So right now I've given the desired capacity as 2 or the minimum as also 2. And minimum 2 EC2 instance should be there to run. Now maximum is we have given it 100. Supposedly we want that the load will be that there will be a heavy load on our web server will be coming so that it could scale up to 100 EC2 instances, but it cannot go beyond 100 EC2 instances. If your load is if you have a heavy load and is there is already 100 EC2 instances, but then it won't go beyond 100 instances because you have already defined that the maximum instance will be 100. Now target group name is we have already created a target group here, and so we have attached the target group here and VPC. Now we want our EC2 to run on private VPC. So we have attached the private subnets here. Then again, this is that launch template. This is how you want your launch template to save as. This is the latest template that it is gonna take. Health check is one. It is gonna check the health check by the type of EC2. So it is gonna check the EC2 instances health check and again the name. So now once you save all this, now your web server is ready to go. Here is the user data, here is the VPC that we have made, and here is the EC2 instance or the web server's security group and everything. So now if you wanna run it, I have already run it. I'll show you. Let's just destroy the older VPC, Terraform destroy. till then I'll show you what all things we have done. Yes, now once it is destroying, I'll show you, I'll make it again. So now recent, I'll show you a picture. Hmm. So yeah, now this is the complete setup. We have created a VPC. Under that, we have created two availability zones, two subnets, two private subnets. We have created an internet gateway. That internet gateway, in one of the subnet, we have attached NAT gateway, and one we have attached load balancer. Now, in the private subnets, we have created a application auto scaling group, in which what it will do is once your EC, we have in the auto scaling group, we have defined that there will be two EC2 instances, and the maximum EC2 instances would be 100. Now, once you once anything comes from an internet, the HTTP request comes from the internet, it goes to a load balancer, and the load balancers uh, with the help of automatic scaling group, it divides the load equally. Load balancer divides the load equally among the EC2 instances which are already present. Now, if the supposedly the load is not enough to for the EC2 instances, so what it does is it increases the number of instances and divide the load equally. Now, if your file needs some now this is what is happening behind in detail. Now this is the user is sending the request to a load balancer. The security group is taking the request. It is sending to via listener. We have created a security group for auto scaling group, and via that it is sending the request to automatic scaling group and two instances. Now our instances, supposedly our file or our server wants some updates to get installed on it. So with the now it needs internet to get install or install the update. What it does, it sends the request to NAT gateway that yes, we want internet and we want these updates to get installed on it. So the NAT gateway sends the request to the internet and sends takes the update and send it to a private subnet. This is the way that you could make your web server with the web server in such a way that the instances get automatically updated or increases automatically. Now, first thing we are gonna go is Terraform validate. It is gonna validate our code. Now, Terraform plan. What it is gonna do is it is gonna show us a structured plan of whatever things we have written. It just increase the size. Now there are so many things. Now first thing that you could see is auto scaling group. Now it's elastic IP, internet gateway, launch template. It is gonna show us. It is gonna show us load balancer, listener, and target group, and everything that we have made is given us a plan. Now we wanna install this Terraform apply. Now we're gonna go for Terraform apply. Now we're gonna write yes, and now it is gonna take some time to get installed because there are a lot of things, so it might take a minute or two to make everything ready. Now, supposedly, once you do this, now you want your now you have to go to the console to get the DNS or the IP address name for the web server in which you're going to go. So in that, I have already written here output with the load balancer DNS name. What it will if we'll go or run Terraform output, now it is gonna give us the value of the DNS IP name. Now I'll show you. Once this is created, now we could get the DNS IP address name here only, and we could search it over the internet, and we could make our web server. Now I have created two EC2 instances for the start. Now you could see the EC2 instances IP will be switching once I keep refreshing the page. So that what it means is it is distributing the load to different EC2 instances as the load is coming. And once there will be enough load, then the EC2 instances gets increased to from 2 to 3 to 4. And once you refresh it, the IP addresses keep on refreshing of first, second, third, fourth. Okay, now everything is running on our command on our computer. Everything is created. We go and check everything that the load is equally balancing or getting balanced or not. So we just go and copy this Okay, we're gonna copy this. Oh, just copy whole. We're just gonna go to a different tab and we're gonna run this. Run this. Now you could see this message is from Pratyaksh web server. We could create anything on a web server. I've created a simple script. Now you could see I refresh this. You could see the IP address that is being changing here 10.0.3, then it is 10.0.4, and as we are refreshing it is keep on switching. What it means is that the load that I'm giving it to the server, it is being distributed to the two instances. Now as the load gets increased, the instance gets automatically scaled up because we have already put a load or the scaling policy there. Now for that, now this is what we have done. Now we go back to our here and we create a CI/CD pipeline for this. Now for that, you could see I've seen this. We have done nothing. We have in this CI/CD pipeline, what we have done is we have named it as Terraform CI/CD, and on push branch it is main. What it means is everything that is being pushed on the main branch, every time it is pushed, it is CI/CD pipeline is gonna run. Now, what all things we have performed in this is we have installed the Terraform version. Now, if you go to the GitHub action and created a CI, there is a this CI/CD pipeline is a default CI/CD pipeline that you get from the Terraform GitHub actions. So you go to GitHub action, you go to actions, you go that you want a sample for Terraform CI/CD. So it gives you this. Now what I have added in this is what we have added. What we have added is we have added the access key and the secret access key for our instance to run. So that we have US East one. So I've added my secret access key and the access key so that it could take the access key from our GitHub secrets. And first it is gonna go for Terraform init, then it is gonna go Terraform plan, then it is gonna go for Terraform apply. Everything is gonna be done. Now I'm gonna go and commit my code. GitHub, and I'm gonna go commit added project. Now I'm gonna go commit it to main. Now wait, I'll push it. Now I'll push it and I'll go to my GitHub actions, and there will be a uh, new workflow, new CI/CD pipeline added project. So, so guys, now I'll tell you. Now whatever we are running will make a Docker file of that. Now the four commands which we used to write while running our uh, file for that of the Terraform file I'll show you. First command was Terraform validate. What it used to do, it's used to validate the code. Now Terraform init is used to install all the dependencies or install the Terraform configurations in our system. Then there was a command Terraform plan. Now Terraform plan, what it's used to give is, right now it's showing nothing because we haven't opened that terminal or the file. Now I'll go and I'll just open this in our terminal, and I could show you Terraform plan. What it gives us, it used to give us the structured layout. Now if anybody else has to use these commands, it has to follow the same steps, or the same commands has to be uh, provided in any of the other systems that we used to provide. Now we have to we have to make a Docker file of it. So in the Docker file we just have to specify these four commands. After that, Terraform apply to apply anything. Now let's just clear everything. So and after that terraform apply used to there. Now this is our docker file in which we have written the name as terraform CICD, and the branch it is used to do is wait, this is our CICD pipeline, and in this we have given the command as first command was set up terraform. Now how do we set up terraform? And this is usually when you used to run it terraform in your computer, you used to you download terraform. So that is what the command is doing is it is installing the HashiCorp terraform from your from whichever site it is gonna do. And after that terraform init command, what it is use running the terraform init command. What it is doing is it is initializing or downloaded all the terraform necessities. Then terraform validate command, it is what it is doing is terraform validate command is checking all the code dependencies. Then terraform plan command, what it is doing is this out tf plan is what it means is when we used to run terraform apply command, we used to approve it yes or no. So what this out dash out tf plan means, it is auto approving or auto uh, approving the commands that we are gonna give. So terra plan out tf plan means we are approving all the plan structure that we have given in the code, and then terraform apply command is what we have given. Now what are these things? AWS access keys. Now you will see in our provider we have given an access key. Now if we have to run it on the CI/CD, we can't provide these access keys, so I'm gonna remove it from here, and I have added it on our GitHub secrets. And now this command will do is it is gonna take the file from the GitHub secret and it is gonna configure our commands from there. Now it is done. Now let's just save it, and after that, now what are we running on a computer? This is a docker file. All the commands will tell you. We are running a nginx server. Now from nginx latest, what it means is we are running the latest pulling out the latest nginx image that is there available in the docker registry. After that we are copying the files. Now the files that we have in our terraform and everything, so we are copying it in our working directory here, and then expose 80. What it is doing is the ports are that we want our container to run is port 80, so that's why expose 80. And then to run a to run a nginx web server, this is the command. I'll show you. This is the command that that you have to write: nginx g daemon off. This is the command that we used to write on our terminal to run our nginx server. So if you want to run this command, you have to in docker file you have to provide the command like this cmd, and then inside of that you have to give the commands in colons. Now this is our docker file. Now this is the thing. Now we are gonna push it and we'll see how the command registry or the GitHub pipeline will work. So let's just write added docker file. I will commit it to main and just push it. I will go back to our this and see our GitHub. This is our GitHub, and we'll check our repository which we made. Now we'll alb, this is the repository. We go to actions and we check this. Now this is the docker file that we have added, and till then we could also see, we go to terminal, how to build the docker file. To build the docker file, you have to write the command docker build. Now docker build, and the file name which we have saved is my server. Now we'll build this, and you could see the docker image is being built. Now it is also building it. Now it is copying all the files in our docker directory and exporting images and exporting the layers. And now just wait for it. Let's just see till our pipeline. Now it is applying terraform. Until then, let's just see a docker. Now our docker is currently building its image. Now you could see it's completed. Now if you want to see, you could go to your Docker. Now you could go to dashboard. In a Docker dashboard, you could see my web server. Now this is the thing that we are currently working. This was our Docker desktop. You could run a new container from it. Then you could see that your container is right now your container. You could see there are two containers. One container we already uh, gave the command docker build. Now this is the another container that we are running. This is running on port 8080. This is the web server that we are running on docker container. Now you could see this was the in our container, and let's just go to our CI/CD pipeline. Now this is our CI/CD pipeline that is currently working. uh, it will run. It is taking some time because the tasks are uh, quite long. Just wait for a CI/CD pipeline to get completed, so that you'll be able to see that we have completed our CI/CD pipeline. And you could see, I'll show you where the secrets we have run. In the settings, you could go to where was it? Uh, in the settings, uh, and secrets and variable, and you go to actions. Now these are the two things that I have stored in my GitHub secrets. So you could see it from there, and you could also go to your console of Amazon to check if these things are getting built or not. But clear the command till then, close it, and yeah, this will run. It will take some time because you have already given so many commands in the to make even the VPC and subnets are being made by your Terraform file, so that's why it's taking a bit of time. But then yeah, you could see applied Terraform. You could see now your GitHub pipeline is completed. You could see the tick and the everything is completed on your GitHub pipeline. So you refresh it, and you could see the pipeline is completed and it's successfully run. So this was a project of running the pipeline, and I'll show you what we have made till now. Now this was a project that we made of auto scaling our EC2 instances and our application load balancers. If the load gets increased on our servers, automatically the EC2 gets increased.